Wednesday, November 18th, 2026, 2:16 and 7 seconds in the morning Pacific Time. I need you to stop what you're doing for one moment. At that exact second, a spacecraft built before most of your parents were born crosses a line no human object has ever crossed. It becomes the first thing we've ever made to sit one full light day from Earth. That means if you shouted at it right now, your voice, traveling at the speed of light, would take 24 hours just to arrive. Then another 24 hours for anything back. A 48-hour round trip for a single hello. Right now, tonight, this same spacecraft is running on a power source losing strength every single year, with only 2 of its original 10 science instruments still switched on. No guessing, no dramatizing, just facts, science, and real stakes, laid out one at a time so you understand exactly what's happening out there tonight. If a distance like that sounds impossible to picture, you're not alone, and that's exactly why you want to stick around and maybe hit follow, because in the next few minutes, this spacecraft is going to teach you something about scale, about time, and about how close we all are to losing contact with the only human object ever to leave our solar system. Here's what's coming. First, you'll learn what a light day actually is and why this one number breaks people's brains. Then you'll walk the entire life of this machine, launch to now, station by station, each stop stranger than the last. After that, 3 things you can do this week, for free, to actually watch this happen with your own eyes. Let's get into it. Its name is Voyager 1. It launched on September 5, 1977, from Cape Canaveral, Florida, on a rocket built to last a few years. Nearly 49 years later, it is still flying, still talking to Earth, and still the single most distant object any person has ever built. Everything that follows in this video happened to one single machine, in order, across almost half a century, and every stage of it leads directly to the light day crossing we opened with. To understand why November 18th matters, you first need to understand light days, because that number is the whole story. Light is the fastest thing in the universe. It moves at 299,792 kilometers every single second, which is about 186,282 miles per second. Nothing carrying information can beat that speed. Not radio waves, not lasers, nothing. Now stretch that speed across a full day. In 24 hours, light covers roughly 25.9 billion kilometers, or about 16.1 billion miles. That distance is called a light day. Every planet in our solar system, even Pluto way out on the edge, sits inside a fraction of that distance. Voyager 1 is about to sit exactly on that line. Picture it a different way. If you drove a car at a steady 100 kilometers an hour, never stopping, no traffic, no sleep, it would take you almost 30,000 years to cover that same 25.9 billion kilometers. Light does it in one single day. NASA's own New Horizons probe, the one that flew past Pluto back in 2015, sits at roughly 9 billion kilometers from Earth right now. Voyager 1 is already almost 3 times farther out than that, and it keeps climbing every single year. The people talking to it aren't using a phone line or a satellite dish you'd recognize. They're using the Deep Space Network, 3 giant dish complexes spaced evenly around the planet in California, Spain, and Australia, so that as Earth spins, one of them is always pointed at the spacecraft. The largest dishes in that network stretch 70 meters across, wide enough to cover most of a football field, just to catch a signal from Voyager 1 that arrives weaker than a whisper, spread thin across 25.9 billion kilometers of empty space. Here's the anchor number to remember because it comes back later. Right now, in 2026, Voyager 1 is roughly 25.5 billion kilometers from Earth, close to 170 times the distance between Earth and the Sun. It is moving away from us at about 17 kilometers every second, adding roughly 3.6 more Earth-Sun distances to that gap every single year. Hold on to that number, 3.6, because it explains everything that happens to this spacecraft from here on out. None of this happens without an accident of timing that only comes around once every 176 years. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune lined up on the same side of the Sun, close enough together that a single spacecraft could use each planet's gravity to slingshot toward the next one, instead of burning fuel it didn't have room to carry. NASA engineers called the plan the Grand Tour. Voyager 2 launched first, on the long route built to eventually reach all 4 planets, while Voyager 1 launched second, 16 days later, on the faster, shorter path aimed straight at Jupiter and Saturn. Voyager 1 didn't start as a lonely explorer of empty space. It started as a planet hopper. Launched 16 days after its twin, Voyager 2, it actually took a faster route and overtook its sibling on December 15, 1977, less than 4 months into the mission. From the very beginning, this spacecraft was built to move fast and look at everything on the way out. Have you ever personally witnessed something in the night sky that made you stop and just stare up in silence? Tell me exactly what you saw and where you were standing when you saw it. Before any of that, back on the ground, a young astronomer named Carl Sagan pushed hard for something almost nobody else at NASA wanted to spend budget on. He wanted Voyager 1 to carry a message, in case anything out there ever found it. That message became the Golden Record, a gold-plated copper disc bolted to the spacecraft's side, carrying 116 images of Earth, greetings recorded in 55 different human languages, and a stretch of music that ranges from Bach to Chuck Berry. It is still out there right now, bolted to the same spacecraft, still riding along on every single kilometer of that 25.5 billion kilometer journey. Along with the images and the music, the record carries recorded sounds of Earth itself: wind, thunder, birds, whales, footsteps, and a human heartbeat, plus instructions etched directly into the cover explaining how to play it, on the small chance something out there ever finds it and doesn't own a record player. In March of 1979, Voyager 1 reached Jupiter and immediately started finding things nobody expected. It discovered a thin, almost invisible ring circling the giant planet, something no telescope on Earth had ever spotted. It also found two brand new moons, later named Thebe and Metis, hiding in the glare of the biggest planet in our solar system. By November 1980, it reached Saturn, and the discoveries kept stacking. It found 5 new moons circling the ringed planet, plus an entirely new ring that scientists named the G-ring after the fact. At that point, NASA made a choice that would define the rest of this spacecraft's life. They pointed its cameras at Saturn's massive moon Titan for one last close look, and that flyby bent its path upward, out of the flat plane where all the planets orbit, permanently taking it away from any future flybys of Uranus or Neptune. From that moment forward, Voyager 1 had exactly one direction left to travel: out. On February 14, 1990, with the last of the planets behind it, NASA turned Voyager 1's camera backward one final time, at Carl Sagan's urging, and took a series of photographs called the Family Portrait. 60 images showing 6 planets from far outside their orbits, including one single pale blue pixel that was Earth itself, seen whole for the first time from that kind of distance. After that shot, the cameras were switched off for good to save power, which means that pale blue dot photograph is still to this day the very last picture Voyager 1 ever took of anything. That final choice to bend toward Titan instead of continuing on to Uranus and Neptune paid off scientifically even as it closed a door. Titan turned out to have a thick, hazy nitrogen atmosphere, something nobody had confirmed from Earth, and that single flyby is a big part of why scientists still consider Titan one of the most promising places in our solar system to search for the building blocks of life. Voyager 2, on its slower path, went on to become the only spacecraft ever to fly past Uranus in 1986 and Neptune in 1989, giving humanity its only close-up look at either planet to this day. For the next 2 decades, it just kept climbing. No more planets to visit, no more moons to name, just distance stacking on distance, year after year, as it crossed a region scientists call the heliosheath, the outer edge of the bubble our sun blows around itself. Think of the sun's bubble like a giant snow globe made of solar wind instead of glass, and Voyager 1 was slowly pushing against the inside wall of that globe, looking for the seam. In 2004, something changed. Instruments picked up a jump in intensity, about 10 times stronger than anything measured before, in a strange magnetic zone scientists nicknamed the stagnation region. Solar wind that normally blasts outward at over 1,000,000 miles an hour had slowed to a crawl right around the spacecraft. Chief project scientist Ed Stone told reporters at the time that the timing of a full exit was impossible to predict because, in his words, no spacecraft had ever ventured this far before. Nobody had a map. Voyager 1 was drawing it in real time. Then, in 2012, everything the mission had been building toward finally happened. On August 25th, at a distance of about 121 times the Earth-Sun gap, Voyager 1 crossed the heliopause, the true edge of our sun's bubble, and became the first human-made object to enter interstellar space, the open ocean of gas and dust between stars. Magnetometer scientist Leonard Berlage, working the data at NASA's Goddard Center, said the magnetic field readings were unlike anything measured before, about 10 times more intense than what they'd seen near the termination shock just before the crossing. That single field reading is exactly the kind of number that matters later, so hold on to it too. Which of these locations in the Voyager story scares you most so far? The magnetic edge of the solar bubble, or the open dark beyond it? And why does that one stick with you? The two surviving instruments still on Voyager 1 aren't just running for the sake of running either. Between 2012 and 2013, its plasma wave subsystem caught the interstellar gas around it ringing louder and at a higher pitch than expected, which told scientists the gas was denser than any model had predicted. That single, still-running instrument is the only reason we know the space just outside our solar bubble is more crowded than physicists assumed for decades, a finding that came from the very same equipment still limping along on borrowed power tonight. In 2013, almost a year after that crossing, scientists finally got hard proof the spacecraft had truly left home. Voyager 1's plasma wave instrument, the very same one still running today, picked up vibrations in the thin gas around it and translated them into sound humans could actually hear, an eerie, rising tone completely different from anything measured inside the solar bubble. That single sound recording was the final piece of evidence that convinced skeptical scientists the heliopause crossing was real, not just a fluke reading. Here's a number that might surprise you. The entire Voyager program, both spacecraft, from design through the Neptune flyby in 1989, cost NASA about $865 million, and keeping both probes running today costs roughly $5 million a year, a tiny fraction of NASA's total budget. Even so, in late 2025, insiders reported the mission was facing a budget cut of around 26%, right as the spacecraft is closing in on this light day milestone. 50 years of continuous data, still coming in from a place nothing else can reach, and its future still depends on a relatively small line item getting renewed year after year. Voyager 1 doesn't even get the Deep Space Network to itself. Those same giant dishes also talk to Mars rovers, to spacecraft orbiting the outer planets, and to missions launching in the years ahead, all competing for a limited number of hours on a limited number of antennas. Every single listening session with a machine 25.9 billion kilometers away has to be scheduled around everything else NASA is doing across the entire solar system at the same time. Here's how weak that signal really is by the time it lands. Voyager 1 transmits with roughly the same amount of power as your refrigerator's interior light bulb, somewhere around 20 watts. Spread that faint signal across 25.9 billion kilometers of empty space, and by the time it hits one of those 70-meter dishes on Earth, engineers say it arrives measured in fractions of a billionth of a watt, so faint that the entire Deep Space Network sometimes has to combine multiple dishes together, listening as one giant ear, just to pull real information out of what looks like almost nothing. 6 years after that crossing, its twin caught up. Voyager 2 reached the same interstellar boundary in 2018, becoming the second, and so far the only other, human object to leave our solar system's bubble. Two machines, launched 16 days apart in 1977, both now floating in the space between stars, both still calling home. Since that crossing, Voyager 1 hasn't stopped moving. Every single day it drifts a little farther, adding that 3.6 astronomical units a year we mentioned earlier, and every year the distance record it already owns just gets more extreme. By the end of 2026, that steady climb reaches the number that started this whole story. On November 18th, at 2:16 and 7 seconds in the morning Pacific time, Voyager 1 crosses the 1 light day mark, 25.9 billion kilometers out, the first object humanity has ever placed that far from home. There's one more marker worth knowing before we get to the light day itself. On February 17, 1998, Voyager 1 quietly slipped past an older NASA probe called Pioneer 10 and became the most distant human-made object in existence, a title it has held, unbroken, for over 28 years now, through every single one of those 3.6 astronomical units it adds every year. To really feel how far 25.9 billion kilometers is, compare it to the nearest star system beyond our own, Proxima Centauri, sitting about 4.2 light-years away. Voyager 1 has spent 49 years covering 1 light day. At its current speed, reaching that nearest star would take roughly another 75,000 years, a timeline so long that entire ice ages would come and go before it arrived. And Voyager 1 isn't even aimed at Proxima Centauri. It's headed somewhere else entirely, drifting through open space with no destination programmed into it at all, just outward, forever, past stars we haven't even named yet, on a path no one alive today will ever see the end of. Let's be honest about what this milestone actually is, because clickbait science channels get this wrong constantly. Voyager 1 is not entering some brand new physical region of space when it crosses one light day. It already left the solar bubble back in 2012. Some space writers have pushed back on the whole idea of celebrating this date at all, arguing that nothing physically changes out where the spacecraft actually is, that the gas, the magnetic field, the plasma readings all stay exactly the same on November 18th as they were the day before. That criticism is fair, and it matters. This is a distance record, not a discovery of new territory, and being straight with you about that difference is exactly why you can trust the numbers in this video. What the one light day mark actually breaks is communication itself. Right now, in 2026, a signal from Earth takes about 23 hours to reach the spacecraft. After November 18th, that number locks in at a full 24, and getting anything back adds another 24 on top. Engineers at NASA's Jet Propulsion Laboratory don't get to have a conversation with Voyager 1 anymore. They send one instruction, and then they wait 2 full days to find out if it worked. Project manager Suzanne Dodd has been blunt about how fragile that link has become. She's explained that both Voyager probes rely on tiny thrusters to keep their antennas pointed exactly at Earth, and if the propellant lines inside those thrusters freeze, the antenna drifts and the signal is gone for good. In her words, losing that pointing means losing the mission, because there would be no way left to get a command to the spacecraft at all. One frozen fuel line, 25.9 billion kilometers away, and 49 years of data go silent forever. Have you ever felt a warning about something huge arrive quietly, almost by accident, before you saw it covered anywhere else? Tell me what that felt like when it happened to you. Power is the second countdown running underneath all of this. Voyager 1 doesn't have solar panels because past Mars, sunlight is too weak to matter. Instead, it runs on 3 radioisotope thermoelectric generators, chunks of decaying plutonium-238 that turn heat into electricity as they slowly break down. That power source loses about 4 watts every single year, and by early 2026, project scientists say the spacecraft is already producing less than half the power it had at launch in 1977. Voyager 1 launched carrying 10 separate science instruments. As of April 2026, 8 of them have been switched off for good. The photopolarimeter went first, back in 1980, right after the Saturn flyby. The plasma science instrument followed in 2007. The cosmic ray subsystem was shut down on February 25, 2025, to save just enough power to keep the rest of the spacecraft alive. Then, on April 17, 2026, engineers switched off the low-energy charged particle instrument 2 after a routine roll maneuver caused a power dip that nearly tripped the spacecraft's automatic shutdown protection on its own. Back in November 2023, Voyager 1 suddenly started sending back nothing but gibberish, meaningless strings of ones and zeros instead of real data, and engineers on Earth didn't know if the spacecraft was dying or just glitching. It took until April 2024, 5 months of testing commands and waiting nearly 2 full days for each reply, before the team traced the problem to a single corrupted chip in the flight data system, and worked around it by rewriting code into unused memory space on a computer built almost half a century earlier. That fix alone is a big part of why Voyager 1 was even still healthy enough to have an instrument left to shut off in April of this year. That leaves exactly 2 working science instruments on Voyager 1 right now, a magnetometer that reads the magnetic field around it, and a plasma wave subsystem that listens for disturbances in the thin gas between stars. Everything else, the cameras that took the pale blue dot, the sensors that mapped Jupiter's rings, all of it has gone dark to buy this spacecraft a few more years of breath. It's a strange kind of triage, deciding which senses a machine gets to keep as its energy runs out, almost 50 years after launch, 25.9 billion kilometers from the people making that call. NASA engineers even had to fight through a memory glitch in 2024 that briefly knocked out usable data entirely, and every single fix had to be planned across a communication delay of nearly 2 full days, round trip. Put those two countdowns side by side, and you get the real shape of this story. Distance is climbing every single day, 3.6 astronomical units a year, no way to slow it, no way to stop it. Power is falling every single year, a little weaker, a little more of the spacecraft going dark. Somewhere out past that one light day mark, those two lines are eventually going to cross, and when they do, Voyager 1 goes quiet for the rest of time, still moving, but no longer listening. Even after the last instrument goes dark, Voyager 1 doesn't stop. It just keeps drifting, silently, no fuel needed in the vacuum of space, carrying that golden record with Carl Sagan's greetings and Chuck Berry's guitar riffs long after every engineer who ever worked on this mission is gone. NASA's own trajectory data shows that in roughly 40,000 years, it will drift within about 1.6 light-years of a small star called Gliese 445, closer to another star than it currently is to our own sun. It won't stop there either. It will just keep going, for millions of years, long after the last radio wave it ever sent has finished crossing the galaxy. Right now, tonight, Voyager 1 is heading in the general direction of the constellation Ophiuchus, and if you download a free stargazing app and point your phone that way on a clear night, you're looking, roughly, toward the same patch of sky this spacecraft is racing into at 17 kilometers a second. You won't see it. It's far too small and far too dark, but you'll be looking at the actual direction humanity's farthest object is heading tonight, which is a strange kind of company to keep with a machine you'll never see again. If this warning reached your own town tomorrow morning, not about a spacecraft, but about something running out of time the same way, what would your very first hour look like? Walk me through it. So what do you actually do with all of this? Here are 5 things, all free, all doable this week, that connect you directly to a story most people will only ever half understand from a headline. First, open NASA's Eyes on the Solar System tool, which is completely free online, and search for Voyager 1 inside it. It shows you the spacecraft's real position, updated with real mission data, not an artist's guess. Do this because right now, tonight, you can watch the exact 3.6 astronomical units a year we talked about turn into a moving dot in real time, instead of just hearing the number. Second, look up NASA's own Voyager mission status page and read the plain language update posted this year. Do this because the agency writes it for regular people, not scientists, and it will show you exactly which of the 10 original instruments are already switched off and which 2 are still fighting, which tells you how close that power countdown really is. Third, find the golden record online, the actual audio and images Voyager 1 is carrying past the edge of our solar system, and spend 10 minutes with it. Do this because it's the closest thing humanity has ever sent to a message in a bottle, and most people who talk about this spacecraft have never actually listened to what Carl Sagan chose to put on it. Fourth, mark November 18th on your own calendar, the actual date this spacecraft crosses one light day. Do this because milestones like this rarely get news coverage the day they happen, and you'll be one of the very few people who watch the moment land instead of reading about it a week late. Fifth, download any free stargazing app, find Ophiuchus in the night sky, and just look at it for 30 seconds. Do this because it costs nothing, takes no equipment, and it's the closest thing to actually seeing where a machine built in 1977 is still headed, alone, tonight, at 17 kilometers every second. None of that costs you anything, and none of it requires special gear, just a phone and 10 free minutes, spent on something that's been quietly happening 25.9 billion kilometers away the entire time you've been going about your normal week. Let's bring this back down to Earth, because the numbers can start to feel abstract if we leave them floating out there. Voyager 1 launched in 1977, crossed into interstellar space in 2012, and on November 18, 2026, becomes the first human object ever to sit a full light day away, 25.9 billion kilometers out, a 48-hour round trip for a single word. Its power source has been fading since launch day, its instruments are being switched off one at a time, and its entire connection to home depends on thrusters small enough to hold in your hand, still perfectly aimed at a planet it left almost half a century ago. If you've made it this far, I know some of this sits heavy, the idea of something so far away, running out of power, all alone in the dark between stars. But flip that feeling over for a second. That machine has been talking to us for 49 years, longer than most marriages, longer than most careers, and it is still, tonight, sending its voice home across a gap that swallows light itself for a full day. That's not a tragedy playing out in slow motion. That's the longest conversation our species has ever had, and it isn't over yet. Think about who built this thing. Engineers in their 20s and 30s in 1977, working with computers weaker than the one inside a modern microwave, somehow built a machine tough enough to still be talking to us 49 years and 25.9 billion kilometers later. Ed Stone, the physicist who led this mission's science for 50 straight years, from before launch until he stepped back in 2022, lived to see both Voyagers cross into interstellar space with his own eyes. He passed away in June of 2024, just 2 years short of the light day milestone we're watching happen right now. But the thing he and his team built is still out there, still working, still faithfully sending its 2 surviving instruments' data home across a gap so wide that light itself needs a full day to cross it. That's not luck. That's just how well something gets built when the people making it truly believe it matters. What is one question about this whole story that nobody out there has actually answered in public yet? Write it below and I will read through every single one and pin the best of them. Its twin is still out there too, worth remembering before we close this out. Voyager 2 crossed into interstellar space in 2018 and is still transmitting today, running its own magnetic field and plasma wave instruments, aging on almost the exact same schedule as its sibling, just slightly closer to home. Somewhere in the next decade, both spacecraft are expected to lose their last working instrument, and mission engineers have said openly that after that point, all that's really left is a radio carrier wave, a simple signal confirming the spacecraft is still alive, with no science data riding on it at all. Even that faint pulse, engineers believe, could keep arriving into the 2030s before finally going silent for good. We'll be tracking this spacecraft right up through November 18th, and when that light day milestone actually lands, we're coming back with the real numbers as they come in, not a guess made months ahead of time, and we'll tell you honestly if anything about this story changes between now and then. That's the promise this channel makes every time. Numbers first, drama second, and no pretending we know more than the data actually shows us. Until then, keep looking up, because 25.9 billion kilometers away, something we built with 1970s technology, running on decaying plutonium and 2 surviving instruments, is still finding its way home, one faint radio whisper at a time, still talking, still listening, still, somehow, after 49 years, not done yet. 49 years ago, a small team of engineers pointed a machine at the stars and just kept talking to it, year after year, long after anyone expected it to still answer back. And tonight, one light day away, it still does.